Today we're going to continue our topic of solving equations, but they're going to have a little bit different feel to it. They're going to have this form, ax plus b equals c. What's a plus b plus c? No need to worry. Those are going to change with each particular problem. They're the constants that are either going to be just constants or the constants in front of the variables, which we know better as coefficients. They can be fractions, decimals, and they can be our integers. Be prepared for just about anything. Here's our first two to get us going. We got 6w plus 4 equals -2. Remember, it's all about the variable. You want to isolate the variable, get it by itself. So really you don't care about the other stuff. Again, all about the variable. There should be nothing attached to it. So we first look and we see that there's a minus, or excuse me, there's a 4. We're going to need to get that a minus. We're going to need to get that out of there. So we're going to use that additive inverse idea. Hey, 4, -4. We know that's 0, so we know that our new term that's going to be carried down is just the 6w, but we have to be consistent. That's why it's an equation. We want to keep that balance. So we're going to have a -6 on that side as well. We now have transformed the equation to something almost what we want. We don't want 6w, we want just one of them. And therefore, we can divide both sides by 6. So we're taking our two skills that we had earlier, being able to use the additive inverse and the idea of that multiplicative inverse, using them together now in one particular problem. Okay. So over here, same kind of thing. We have, again, notice it doesn't always have to be the variable and then something. Again, it can just be any type of that form. So here we go. We're going to subtract 7 from both sides. So hopefully that's what you were thinking. Again, it's all about the variable. What's attached to that variable. We don't really care about that 2 for right now, but the first step, anything that's added or subtracted to that variable term. That should give us, if we did our arithmetic correct, we should get -2n equals -5, because that's 2 and a -7 combined. It's going to give you a -5. And let's see here as we go through. And try to do our solutions, we would go through and have n equals, and be very careful, even as you're writing and talking, be very careful, because a negative divided by another negative, we all know is a positive. So we would have a positive 5/2. Probably if you'd want to, you probably might want to check your answers before you moved on. Let's see our next examples here. We have that we want to solve 2/3 of a v minus 4 equals 3. And sort of wrote up the steps here. As you can see, again, trying to do that transforming, always adding or subtracting first. That last step, wiping that coefficient to a 1. Not too bad here, but don't let that fraction mess you up. The fact that you're going to have to go through and multiply by 3/2. So that 7 times 3/2 would be 21 halves. Again, you want it to be a nice one of those variables. Likewise over here, same procedure. Be very, very careful on those fractions. 5/2 is what we're going to multiply to clear that coefficient. So -8 times 5/2. Remember that 8 is like an 8/1. So this is really just bringing in a lot of our older information and bringing it together. But you do have to be very, very attention to detail to make sure you can handle it correctly. Let's look at two final examples. The fact that one thing that you have to watch out for, and you can see, is each equation gets a little more intense, just like a sentence. When you read it, sentences that you learned how to read get more intense as you go and you learn how to read. The thing that can happen here is that you might have to do a little housekeeping. You might have to go through and combine some like terms. You'd have 4a and negative 7a. Those are like terms. Just think 4 apples and negative 7 apples. And everything else is going to carry on down. Okay? Then, wow, hey, this is just like the problems we were just talking about the last couple minutes. The fact that there is one variable term and you're going to combine those constants together. Again, using our additive inverse idea. Whatever you do to one side, you are always going to do to the other side. I could add 1,000,000 to one side, and that's okay as long as I add 1,000,000 to the other side. Almost forgot the negative. Just ready to remind you the fact that having to watch out for that negative. 12 divided by negative 3 is going to be a negative 4. Whatever that coefficient is, that number in front of that variable, if it's a fraction, decimal, a positive or negative, that whole entire number has to get divided by both sides. And again, we can always go back and check in, plug a negative 4 into our variable, do the arithmetic, and hope the left side does equal the right side. And I do encourage you should always check. We're not going to check right now just so we can get through some problems, but you definitely always want to check. Here you'd have 1x negative 4x. Definitely are two like terms. So notice how we took our information about knowing like terms, took our information about solving equations that had just one step. Whew, everything is meshing together here as we go forward. There's a plus 5. Again, remember, always doing the opposite. That's looking pretty good. Negative 3x equals a 6. We're going to go and, as our final step, always to clear that coefficient. Ooh, a lot of negatives here. We would end up getting a negative 2 that we could plug in and make it certain. And we would, if we plugged in a negative 2 in for x real quick, we would end up getting 11 equals 11. So we know that that checked out. So remember, your biggest thing, your biggest ally in being able to solve equations, to get that skill, practice, practice, practice. Always keep talking to yourself to know what you do each step of the way. You can do it.